Hey everybody in Econ 140 land. Today I'm going to show you how to walk you through the steps of, because you already know a little bit, how to run Logit and probit models based on Lab 5, which is an optional lab, just giving you guys an opportunity to practice your skills in terms of how to run a qualitative choice model. Remember, a qualitative choice model is a model where your dependent variable, your y variable, is binary. So it's 1 or 0. So we have in the Koop data sets whether or not a person has had an affair, whether or not a person is a smoker, whether or not a person chooses to commute. All those data sets look at that choice, that decision of whether or not to do something. We can think about in macro terms, maybe whether or not a country has a coup or has a fixed exchange rate regime or something like that. So there's lots of different situations where you want to look at basically a qualitative question, not a quantitative question. And so we won't have a marginal effect or a marginal change in y. Instead, what we're going to get with our marginal effects is the probability that that outcome is 1. And so what we're going to do is we're going to go through and walk through running a Logit or a probit, which are two models which estimate the probability that d is equal to 1, and look at those marginal effects, spend some time interpreting them, spending some time looking at some of the different ways that we can do that. So I'm going to go ahead and flip it back over to my computer screen here. And I've got my Stata open, and the first data set I want to import is I'm going to import the AFFAIR data set. So this is affair.xls from the Koop data set, and I'll get this loaded for you guys all on Canvas, or you can always get it from the textbook website, but it's right here, and it's AFFAIR. And this is looking at, if I remember correctly, this data set is from a magazine article, I think they say. Basically looking at whether or not people have an affair and a handful of explanatory variables. Doesn't matter where it's from. They talk about it in the book. We want to make sure to import the first row as variable names, and then we can see here we have affair, we have some constant, we have whether a person is male or not, the number of years they're married, whether I think it's how many kids they have, or whether or not they have kids, whether or not they consider themselves religious, what their years of education are, and whether they consider the marriage happy or not. So I'm going to go ahead and import that data set, and I'm going to go ahead and summarize it so that I can talk a little bit about it. So I can see here my dependent variable, whether or not a person has an affair, is a binary variable, 0 to 1, right? The mean of 0.249 tells me that almost 25% of this sample have had an affair. The binary of male, with 1 being male and 0 being female, tells me that about 47.5% of this sample are male. People have been married as little as 0.125 years, so not even a year, and as much as 15 years, so a big variation there, although the average is 8 years of marriage. Marriages, about 71.5% of marriages have children, although another 30 some odd percent, almost 30%, have no children. 43% of these marriages consider themselves religious, or respondents. The average years of education is 16, with 9 being the minimum and 20 being the max. And then of these marriages, 70%, almost 71%, consider themselves to be happy. So that's our data set that we're working with. And we can see how basically if we ran a simple regression of affair with, say, male, years married, kids, religious, years education, and happy, we get some not very significant results, and we don't really have a way to describe them, right? These coefficients are not going to be useful for our purposes in describing the decision to have an affair or not. So what we have to do is we have to use a probit or a Logit model. And there's not a lot of difference between probit and Logit, so you're free to use either. And I can show that to you by going through and running both. And that's what I'll ask you to do in the lab, is I'll ask you to go ahead and run a Logit, and the command for that is just Logit. And we'll look at affair, male, years married, kids, religious, years education, and happy, to see how those variables affect a person's decision to have an affair or not. And you want to remember that we're thinking about these in terms of being utility maximizing choices. So we want to be able to predict whether a utility maximizing individual will choose to have an affair. So we can run that Logit model, and that's going to give us some estimated coefficients, some standard errors, and some p-values. And we can use the same statistical techniques we've used before to say things like, wow, years of education is not very significant. Whether a person is happy in their marriage is, whether the family or whether the couple considers themselves religious is, and years married is borderline, but it is significant. But we can't really interpret these coefficients. What we need are the marginal effects. And I do have a do file for this purpose that I can open for you guys, and I'll post this for you all on Canvas, and I'll go through, and it talks about the different ways you can use to run a Logit and a probit model. And the whole point is that you have to get the marginal effect. And there's two ways to get the marginal effects. You can get the marginal effects generally or the marginal effect at the mean. And we're going to want to get the marginal effect at the mean, but you can do both. It's up to you. So here we go. I put in the command. So the command is margins, comma, dy dx, and then in parentheses star, and that's just telling it what I want the partial the partial derivative of. And what I'm asking is for the marginal effect, the partial derivative of each of these coefficients at the mean value. That's what that command is telling me, is get the marginal effects of these these. So here we go, and we get our marginal effects here. And this is what we can interpret. The way we interpret the marginal effects of our independent variables on our dependent variable is basically how much they can predict of the probability that a given person will have an affair. So here we have the mean values for all of our variables, right, that we talked about before. And so at these means, what are the probabilities that D is going to equal 1 or Y is going to equal 1, that our utility maximizer is going to have an affair? So again, we can see that our most significant variables are going to be here religious and happy. And they have about the same size effect. So if a person considers themselves religious, that is going to have a negative effect on the probability that they have an affair. Considering oneself religious is going to tend to decrease the probability of having an affair by about 15%, holding all other variables constant. Same thing can be said for a happy marriage. If you consider your marriage to be happy, that's going to tend to decrease the probability that you have an affair by about 15%, holding education, religiosity, kids, years of marriage, and maleness constant. We could also talk about years married being somewhat significant, but the marginal effect is really, really low. So here we'd say each additional year of marriage is going to tend to increase the probability of having an affair, but by less than 1%. So it's not a really strong factor. We could say maybe, if you're every decade you're married is going to tend to increase the probability of having an affair by 1%. Or by 8%, but that's not a great measure. So what we really come out with here is that the factors that affect the probability that a person has an affair tend to be religiosity and whether they consider their marriage happy or not. Make sense? We can do the exact same thing with a probit model. So I'm going to do a probit of affair, male, years married, kids, religious, years educated and happy. Oh, see, that's why I like to just that's another reason why I like to just bring the variables down from there. Typos can be tragic. And so then I get my coefficients. I get a pseudo R squared here. And I get, I still need to, though, calculate my marginal effects. So I'm going to look for the margins, and I'm going to say, I want to copy my command just right. I want to say dy dx, put that asterisk in there to let it know what I want. And I want to say at means. Get the marginal effect at the mean. And here we have pretty similar marginal effects, right? We still have the same level of significance for happy and religiosity. We'd interpret those coefficients in the same way. We see that years married is also pretty significant, but it's also a really, really low level of effect, a really low probabilistic component. So if we're trying to estimate the probability that someone has an affair, just knowing whether or not that person considers themselves religious and whether or not they consider their marriage happy, that gives us almost a third of that probability. So having, the marginal effect of years married isn't going to give us a lot unless they've been married a very, very, very long time. We could say generally that years married tends to have a positive effect on the probability one has an affair. We could also talk about the significance of years of education, kids, and maleness on the probability one has an affair. They're all positive, though not statistically significant, but that gives us sort of a sense of how that works. I'm going to go ahead and clear this data set out and open up another one that looks at the probability that a person commutes. So I'm going to put clear and import another Koop data set. This is from exercise 8.1. And this data set contains 390 observations of individuals on their commuting choice between public transportation and taking a private car. So let's get that data set in here. It's going to be commute XLS. And one thing that's important to keep track of with this data is you're going to want to make sure you keep track of whether your D equal to 1 means commute or not. So I'm going to write it in here for my notes. And so choice equal to 0 if the individual takes public transport. D equals 1 if the individual takes a car to work. D equal to 0 if public. So basically now what we're looking at is how our explanatory variables that I'm going to summarize here affect an individual's decision to drive to work or take public transportation. And we're going to look at the marginal effect of income, where income is in thousands of dollars, and the marginal effect of distance to work in miles. And so we can see here the average income is $62,000, the maximum is $109,000, the minimum is $10,000. And distance to work, the average is 20 miles, almost 21 miles, with some people having up to 49.967 miles, some people having as few as 0.1 mile to work. And now I'm going to use a different command. This is a great shortcut, especially if you get bogged down a lot with typing. Just using the command dprobit will give you the marginal effect, and I want to look at the choice of whether to drive a car or not, income, and distance as my explanatory variables. So instead of probit, now I'm using dprobit, and that's going to give me a probit model with the marginal effects already built in. A little bit faster, right? So here we go. We can go through and see, here's my command, dprobit, choice, income, distance. And here I've got probit regression, reporting marginal effects, my observations, my pseudo R-squared. And now I can see here, I've got a positive relationship between income and the probability a person takes the car to work. And I have a negative effect between distance and the probability that a person takes a car to work. So each additional $1,000 a person earns in terms of income is going to increase the probability that they drive a personal car to work by about 1%, almost 1.5%, right? 0.0134 or 39, sorry. So about 1.4%. Each additional mile that a person lives from work is going to tend to decrease the probability that they take a car by about 2%. And we can see both of our variables are statistically significant. Our p-values are small. Our standard errors are much smaller than our marginal effects. And our confidence intervals do not contain 0. So we can interpret these results by saying each additional mile a person lives from work will tend to decrease the probability that they take a personal car to work by 2% holding income constant. Cool? That's qualitative choice models. So hopefully you find it fairly simple. It is a lot. It's different commands than we used before. It's different interpretations, but what we're using these probit and logit models to generate that sigmoid function, that S-shaped function, to see, is someone going to pick 0 or 1? And we only have values for 0 or 1, but we're also estimating them with these linear effects that don't just give us that binary outcome. So what the marginal effects give us is the probabilistic effect of our explanatory variable on d being equal to 1. Cool? Let me know what questions you have. Take a look at the lab, and have a great day.